A very premium projectile motion question. This question is being asked in paper 2 also again and again. What I meant by saying this question means this type of question. Okay, cool. So let us see how we solve it. A boy throws a ball horizontally at a speed 15 meter per second from the top of a cliff. Very good. Let me draw a cliff 80 meter above the surface of sea. Okay, this is sea. Nice. Okay, this ball is launched horizontally with a speed 15 meter per second. Cool. How will this ball go? So it will of course cover a parabolic path, or it will land something like this, right? Okay, cool. So what is the distance from the bottom of the cliff to the point where the ball lands? That means they're asking the distance between this is the bottom of my cliff, and this where the ball lands. So basically this sky blue distance, that means the range, that means the distance covered in the x-axis, right? Okay, cool. So to find out that, I simply know the velocity of the x-axis. Velocity in the x-axis is 15 meter per second, right? And they have asked the distance in x-axis, right? And I know that this velocity does not change because there is no air resistance. They have written air resistance is negligible, so I can simply use speed equals distance over time, right? So from here I can say distance is speed into time. So what is stopping me from finding out the distance covered in the x-axis? I already have the speed in the x-axis, right, which is 15. But do I know time? Nope, I don't know time. How long it takes, for this ball to reach from here to here? I don't know that time, right? So now to find out that time, I need the help of y-axis. Cool. You must be wondering why have they given this 80. This is why they have given this 80. Cool. So now I don't know how much time it takes from for this ball to reach, like to cover this much distance in x. But you see, when the ball is moving forward, same time ball is moving down also, right? In the same time, when it is covering the sky blue distance in the x-axis, in the same time the ball is covering 80 meter displacement in y-axis, right? So I know the initial velocity in the y-axis is 0 because you have only given it horizontal velocity, right? I know acceleration is g, acceleration due to gravity, right? And what else I know? I know the displacement is 80 meters. So what do I need? I need time. Okay, so I'm going to use the second equation of motion basically. Yeah, s equals ut plus half at square, right? So ut minus half gt square. Okay, let me take it plus. Okay, cool. So if I put the value 80 equals u is 0, so half into g is 9.8. I'm just taking it 10 for the sake of calculation. So I get it as 5, right? So 80 over 5 equals t square. So t from here comes out to be 60 square comes out to be 16. Okay, so t comes out to be 4 seconds. Cool. Once I know t, it's very simple for me to find out this sky blue distance because this is nothing but 15 into t, right? So the distance in the x-axis is speed in the x-axis into time taken, which is 4 seconds, which comes out to be 60 meters. So let us see which is the correct option. So option B is the correct option. So this is very important question. They ask this type of question in paper 2 as well. I hope you have understood.